Because I'm constantly showing you the maps at the end of my hikes, I thought I would explain a little more detail about the coordinate system that is used on those maps. It's called Universal Transverse Mercator, or UTM Coordinates. It's basically a metric system. But the advantages of the UTM coordinate system is that there is a square UTM grid that is superimposed on the USGS quadrangle maps. If you go back and look at my hikes and look at the maps that I show at the end of the hikes, you'll notice that there's a rectangular grid on them with numbers on them. And that's the UTM coordinate system. Now, because of the way it works, there are no negative numbers. I'll explain more about that later. But like, for example, when you have latitude and longitude, if you're at 78 degrees west longitude, in some coordinate systems that's represented as minus 78. Plus 78 would be east longitude. But in the UTM coordinate system, there is no east or west designators, and there's also no north and south designators. You only have eastings and northings. Eastings and northings. The coordinates in UTM are always decimal. There's no degrees, minutes, or seconds to worry about, and the distances are in meters. So you can directly add and subtract your positions to get distances. Now, one thing that's critical, and I'll show you this on the example I'm going to use today, you have to set your GPS to the same datum as what's shown on the map. Now, normally it's one of these three. It'll be either the NAD 27, and on a Garmin GPS, this one is marked NAD 27 CONUS, or it might be NAD 83, or it might be WGS 84, one of those three. So it's very important. If you're using a GPS and a map together, you have to set your GPS to the same datum, and it'll be shown in the lower left-hand corner of the map. So I said that the UTM coordinate system only has eastings and northings. So here's some information about the eastings. There are 60 zones. The Earth is divided up into 60 easting zones. Each zone is 6 degrees of longitude wide. Zone 1 starts at the international dateline. Okay, it doesn't start at Greenwich. It starts at the international dateline, which is 180 degrees west longitude, and the zones increment towards the east. Okay, so in the UTM coordinate system, there's only eastings going this way, and there's only northings going this way. So this is a representation of one of the zones, one of the 60 easting zones. Each zone has a central meridian, and that would be this one that's perfectly straight up and down. And it is arbitrarily assigned a value of 500,000 meters. Okay, so every zone has its own central meridian, and every central meridian is arbitrarily assigned a value of 500,000 meters. So if you're here, you're at 500,000 meters easting. Now, if you move to the west, this value decreases, okay, but because it's set at 500,000, it never gets to zero or goes negative. And so from your 500,000 easting here, if you're over here, you might be at 400,000, 300,000, 200,000. As you go towards the east, it's 500,000, 600,000, 700,000, 800,000. Okay, so from the central meridian, you got 3 degrees this way, and you got 3 degrees this way. Now, this meridian is perfectly straight up and down, but if you're anywhere else in the zone, your meridians are going to be curved like this. Okay, and that curve shows up on the maps as slanted lines, because short sections of these curves on the maps I'm going to show you look like a piece of a straight line. You'll notice that they're usually slanted one way or the other. If you have a map for the exact center of the zone, that grid line is going to go straight up and down like that. Okay, and now in UTM, you also have your north and south is called a northing. And these are meters north relative to the equator. Now, there are 20 northing zones. 19 of them are 8 degrees of latitude tall. And the one at the very top here, one of the zones is 12 degrees of latitude tall. And they are designated by letters, starting down here with the letter C, and they go C through X, except that they skip the letters I and O so they don't get confused with the numbers 1 and 0. So starting down here, your northing is C in zone C, and it works its way all the way up to here, which would be zone X. Now, the UTM coordinate system starts at 80 degrees south, and it extends all the way up to 84 degrees north. These polar areas up here that are shaded use a different coordinate system called Universal Polar Stereographic. Now, hardly anybody uses these because hardly anybody is navigating up here at the poles. But if you're up here in the polar region, the coordinates at the South Pole start with A or B, and if you're at the North Pole, the coordinates start with Y or Z. And because there's no negative numbers in the UTM system, if you're in the northern hemisphere, your northing numbers start at 0 at the equator, and they extend up to 84 degrees north, which is about 9 million meters, okay, plus or minus. Now, the same point on the equator, if you're in the southern hemisphere, this same point starts with the number 10 million, and the numbers go down the further south you are until you get down to here, you're down around 1 million, plus or minus. This is probably the most confusing part of the UTM system, but that's the way it works. And the purpose of it is to eliminate negative numbers. As an example, I'm going to use the USGS quadrangle map for Manassas, 1994. This is near where I live. Now, this is the lower left-hand corner of the map. Okay, it's produced by the USGS, and you'll see right here it says North American datum of 1983, NAD 83. That is what you would set your GPS to for this map. So you have to look in the lower left-hand corner to find your datum. And here it is right here, North American datum of 1983. So you set your GPS to NAD 83 right there. Now, the other thing that you get from the bottom of the map is your magnetic declination. Now, on these maps, true north is pointing straight up. So this line with the star on it is exactly vertical. That's true north. I'll show you a different map in a minute, but these UTM lines are almost always slanted either to the left or to the right. And so in this particular map, that says GN, that stands for grid north. That's these UTM lines. And in this map, the grid north is sloping to the left like that. And then MN is magnetic north. Okay, and it's off to the left even more. Now, when you're using these maps in the field, the only thing you have is you have your grid north, because you've got your grid lines, and you've got your compass, and that's magnetic north. So you need to calculate the difference between GN and MN. And if you study that diagram for a little while, you'll see that it is this angle minus this angle. So 10 degrees is 9 minutes and 60 seconds minus 1 degree 32 seconds gives you a declination of 8 degrees and 28 minutes. And for practical navigation, you can just round this. So this gets dropped and it's 8 degrees, western declination. Now the earlier maps like this one's from 1994. Sometime after this, they started actually putting the UTM Zone Designator on the maps. This one does not have it, but the grid zone designation for this one is 18S. So that means I'm in the Eastings Zone 18, and my Northing Zone is the letter S. So my grid zone designator is 18S. Okay, so finally let's take a look at this map. This is a map of downtown Manassas, the way it looked in 1994. And this should look similar to the maps that I show you on my hikes. And here I've drawn in the 8 degrees of western declination for my compass. So there's a grid line right there. That's grid north. And then there's 8 degrees to the west, and there's magnetic north. So you want to set your compass, declination, 8 degrees to the west. Now, on my Garmin GPS, if I look at my position on my Garmin GPS, this is what I see on my GPS. I see 18S, that's my zone. Then I see 0285217, that's my easting in meters. And then my northing is 4292067 meters. Okay. Now, you'll notice on these maps that the big numbers are 85 and 86. I don't know if you can see it on the camera, but there's actually a 2, a smaller 2 written there. That's 285,000 meters. This is 286,000 meters. Okay, 285,000, 286,000. So if you look at this number for my easting, you can forget about the 0. That's 285,217 meters. Okay, so there's 285,000, there's 286,000. So I am in between 285 and 286. So I'm about, there's 285, there's 286, so I'm about here. And then my northing is 4,292,067. Now you'll notice I put a 92 here and a 93 here. That's 92,000 meters north. This is 93,000 meters north. So I'm going to ignore the 4,200,000, and I'm just looking at 92,067. Well, that's in between this grid line and this grid line, because this is 92,000, this is 93,000. Okay, so that grid line's there, right there. 92,067 is just a little above there. Now you'll see I put an X there I ate lunch right there, near there today at the intersection of Main Street and Center Street right there. So I stood there at that intersection and saved this on my GPS. So this is what it looks like on your GPS. And what I do is I ignore the zone because I'm almost never going to go from one zone to the next. And you can, these first two digits, you can basically ignore them because you'd have to move a huge amount of distance for those numbers to change. And so you just look at your easting, which is your first number here, and your northing, which is your second number there, and you just plot it like you would XY coordinates on a chart. So hopefully that explains a little bit better about the UTM coordinate system. This is what it looks like on a Garmin GPS. I'm sure the other ones look very similar. And for most practical applications, all you need to do is look at these least significant digits right here and plot these on your map. Hope that helped.